All right, we're going to journey into the next and final big topic in Cal 1, and that's going to be antiderivatives. So the name leads to exactly what we're going to be doing. We're going to be undoing derivatives. So by definition here, an antiderivative means that if you take the derivative of the function, then you get the function f. So big F is an antiderivative if when I take f prime, I get the function. Then we say that f is an antiderivative of little f. Big F is the antiderivative, little f is the function. All right, so if we know we're looking at the function 2x, and with power rule, we might know like, oh, well, if I take the derivative of x squared, then I get 2x. Therefore, big F prime is equal to 2x. And so big F is the antiderivative big F equals little x squared, because when I take the derivative of that, so antiderivative of 2x is what I should say. Because when I take the derivative of x squared, I get 2x. So this is our antiderivative here. However, one thing that's really, really important is I could have any number right here, and when I take the derivative of that number, I still get a 0, no matter what that number is, right? And so what we end up doing is we end up saying the antiderivative has this like an arbitrary constant c, because it's possible that I could have had some number here that when I took the derivative of that, it just went away. Now we need some more information to figure out what C actually is. So we're going to call this the general form of the antiderivative. And then we might be able to find a particular form if we know what C is or some initial value on there. All right, so let's go ahead and look at some examples of finding antiderivatives. So if little f is 3x squared. The big question is what is big F so that little, or f prime, big F prime, which is little f, is 3x squared. And we kind of, at this first part, we're going to work backwards and think about, okay, what does big F have to be so that when I take the derivative, I get 3x squared? If I were to kind of undo the product rule, then this must have come from the exponent. So the exponent must have been 3. And let's see, if I take the derivative of x cubed, I get 3x squared. But again, it's possible that I could have had a constant, and when I took the derivative, it went away. So this is my full antiderivative of 3x squared. All right, let's look at 1 over x. What function, when I take the derivative of it, do I get 1 over x? Hopefully you say that that's the natural log of x, and then I'm going to add c. Now, one thing when we do antiderivatives, I can't take the natural log of negative numbers. And so I'm going to restrict that domain and say like I can only do that of positive numbers. And so that's one thing that's going to be in particular about taking the antiderivative of 1 over x is when I'm like, oh, well, natural log of x is has the derivative 1 over x. So this is my antiderivative, but on domains of natural log, I can only have positives, so I include those absolute value bars. All right, if little f of x is cosine x, again, we need to think about what function when I take its derivative, do I get cosine x? So I taught you guys this little circle, right? And derivatives went around in this circle. Well, guess what? Antiderivatives go the opposite way. So if I start here with cosine, then its antiderivative must be sine. And then again, I might have had some constant that when I took the derivative, it went away. So notice we always have that plus c term. All right, and then let's think about e to the x. Well, what is a function that when you take the derivative, you get e to the x? Hopefully you say it's e to the x. And then again, I might have some arbitrary constant.